Hello, this is part one of information regarding polynomial functions of higher degree. In this video today, we're going to start off with just some basic vocabulary that we're going to need to move forward in this section. Okay, so I need you to remember words like what is a constant as it pertains to a polynomial function. Okay, well, that might look like f of x equals a. Okay, it would have 0 degree. And graphically, you would see it as a horizontal line. Okay. Second, what is a linear function? Okay, well, we know f of x would equal mx plus b in its basic form. 1 would be your degree. And it looks like usually a diagonal kind of line, or the fancy math word for that is it's an oblique line. Diagonal, oblique. All right, quadratic. All right, so basic quadratic, f of x equals ax squared plus bx plus c. 2 would be your degree. And we know that graphically to be a parabola. Okay. Cubic function. Okay. F of x equals ax to the third plus whatever is going on in between all the way down to your constant a. So it's a degree of 3. Okay, and we know that little cubic graph. Oh, let's just make this fancified. Okay, something like this. Okay. And the last one we'll put on here today is quartic. I bet you can guess what this one is. Okay, so something like ax to the fourth, whatever's going on in between, all the way to the constant. 4 is your degree. And if you were to put that on your calculator and take a look at it, okay, it would almost be like a parabola, huh? Okay, coming around, something like that. All right, so there's just some basics, vocab as we're jumping in here. Some other things when we're looking at a polynomial function. Let's say we have, I'll put this back to black. Our f of x is of the form a to the n, x to the n, plus a to the n minus 1, x to the n minus 1. So we're kind of going down here, not kind of, but we are going in descending order, such that we go all the way down here to your constant. All right, so then some words to discuss in regards to this polynomial. We could even just say this is some basic vocabulary that we can use to describe our polynomial function. Let's slide this up just a bit. All right, so one word we would have is that it is in standard form. Okay, so if we're talking, hey, that polynomial's in standard form, that's pretty cool. We just mean it's in descending order. Okay, just like this one I put up here generically. Descending order. Okay. Coefficients. We usually talk about coefficients when we're looking at a polynomial, like f of x equals 2x to the third minus 4x squared plus 5. Okay, so if we're talking the coefficient of the x cubed term, it would be 2. Coefficient of the x squared term, it would be negative 4. Okay, so just your basic words with coefficient. Okay, leading term. Leading term. Okay, usually you'll see that to be like a sub n, x sub n. Okay, so in our generic, okay, there's your leading term, and then again, that's assuming that we are in standard form, meaning it's in descending order. Okay. Another way I was thinking about coefficient, you could think of this as the number that's multiplied with a variable, if I put it in words instead of just showing you with an example, okay, or variable. Okay, so then next up would be your leading coefficient. Okay, so the leading coefficient is the coefficient of the leading term. So in our example here, it's just your a sub n. Okay, it's this first, okay, coefficient. And then lastly, constant term. Okay, so the constant is our a sub 0. Down here, it's going to be your number without a variable. Okay, that's going to represent your constant. Okay, so while I have you here, I'm going to go just a little bit further. I don't want to make this video too long for you, but I want to go over something handy to know, and that's going to be talking about, how about we do something like this, local extrema and zeros of your polynomial. Okay, so my thought is for this one, okay, what I'm going to go with on this is that a polynomial function, I'll just say poly function, of, you know me, I like playing with this marker, of degree n has at most, okay, so at most, I get to play again, n minus 1 local extrema, okay, and at most, n zeros. Okay, so now you're out there thinking, all right, why is that such a big deal? Okay, well, let me make a little sidebar here. In fact, we'll just put this back up to blue. So in other words, here's the deal. If you have a polynomial, your degree is n, okay, the number of zeros is at most n, okay, and the number of local extrema is at most n minus 1. Okay, so let's have an example. Up we go a little bit here. Okay, so let's say that our f of x is going to be 4x to the third plus 3x minus 1. Okay, so we want to talk about what's the degree, how many extrema, and how many zeros are possible for our polynomial function. Okay, so we'll start out. You would name the degree. All right, so we are in standard form or descending order. We see our degree to be 3. Okay, the number of possible zeros. Okay, possible zeros. At most, same as the degree, so 3. I could say number of. Okay, and then lastly, we would have the, let's put it here, number of possible extrema or extreme values. Okay, remember that's going to be n minus 1. So if our n is 3, we're going to do 3 minus 1, so 2. Always one less than the degree. Okay, and remember extreme values, that's your local min, local max, absolute min, absolute max, depending on what your graph's doing. Okay? All right, so at that point, I think I'll leave you with this. Make sure you make a mental note or something here with this last section, because this bit of notes right in here be very useful to you moving forward. Okay, I'll see you in part 2 in just a little bit. Thanks for watching.